All right. So now what we're going to do is we're going to look at what happens when we multiply terms that have exponents. How does that work? What can we combine? What can we do? And all of that. So I kind of like to think of all this sort of as like sorting a bunch of Legos that get dumped on the floor, and somebody gives you a bunch of buckets and says, okay, I want the red Legos in this bucket, I want the white Legos in this one, I want black Legos over here, I want blue Legos over here, green, blah, 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 right? And so you're sort of putting this stuff all together just so you can see what you have. And so when we multiply things together in algebra, it's not like multiplying two numbers together where you're just going to get one easy, concise thing. You get these like really weird terms that you multiply by each other, and you have to try and make sense of it. And the way we do that is through simplifying them. And in simplifying them, we have to know some rules about how to work with exponents, because exponents are a big part of what we're going to see. So this little inset box we got here, it says to multiply two powers that have same base, and that's really important, same base, you add their exponents. So I'm going to show you why this works. Okay, so this example that they have here, this b third times b to the fifth, they just kind of say, okay, add 3 and 5, right? Go add, and 3 plus 5, and then you get b to the eighth. All right, that's great. Why does that work? So the reason it works is because if you take b to the third and you multiply it out, because this is what this means. B to the third means this. It means you're multiplying, you're repeatedly multiplying b. All right? And then if we do the same thing with b to the fifth, you'll see 2, 3, 4, 5. You'll see we're multiplying that out 5 times. So this right here represents b to the fifth, and this right here represents b to the third. Well, if you have them all written out like this, why wouldn't you just write it with one base instead of two bases, right? And then just count and go 1, 2, 3, 4, 5, 6, 7, 8. And there you go. And so the fast way of doing this that somebody figured out probably pretty quickly is that, well, hey, instead of having to write everything out, if I know I'm multiplying two things and they have the same base, I can just add their exponents together, and we're in good shape. So that's the rule. Now let's look at some real applications of how this works. So let's look at letter A here. So it says simplify this expression. Now the thing is, you have to multiply. You're multiplying like terms. You got to multiply like terms. And I know that's not a commonly held like phrase that's used in algebra circles, but I like to use it because I think it's applicable here. So if you look at this and this, and you look at, well, what would like terms for this be? Well, for your numbers, right? I don't know what I just did there. For your numbers, like 6, the like term with 6 would be the other coefficient, which would be 2. So what I always do first is I always multiply my coefficients. I always do that first. I always multiply my coefficients. So I'm going to go 6 times 2, and that's going to give me 12. And then I multiply like variables with each other, right? So variables that are the same as each other. So in this case, I only have one variable, and they are the same as each other. So I have n to the third, and I have n to the seventh. And so I'm going to have an n. And then we do our new trick we learned, which is take 3 and 7, and we're going to go 3 plus 7, and we're going to get n to the 10th. And that is that. That is how that works. So that's how 6n to the third times 2n to the 7th becomes 12n to the 10th power. All right, so let's look at this next one. So we have 3 here, right? So let's start with our coefficients. All right, so let's stick with our color scheme here. And we got red, so we got 3. And we don't have a number in front of the second one, but you should always know that every term has a coefficient. It's just that they don't ever write the number 1. So it does have a number. It has the number 1. It's just not written because they are lazy, and I don't know what I just did there, but they don't feel the need to constantly do that, right? So let's multiply our coefficients then, right? So it's basically 3 times 1. And that's easy enough, right? Now let's do let's start with one of our variables because we have two different variables. Let's do p's. So we got p and p to the third. And again, reminder that p equals p to the 1 power. Everything has a power, right? Whether it's written or not, it is to be determined. But everything has a power. And if it's not written, it means it's got the power of 1. So p isn't just p. It's p to the 1 power, and then we have p to the 3rd power. So when I combine those, I get p to the 4th power. All right, and then we'll do our t's. And so for our t's, we've got t to the 3rd power, and we've got t to the 4th power. So you would have t to the 3 plus 4, right? And you go 3 plus 4, and that would give you t to the 7th power. And that is the answer to that one. If you don't ever do this, this would be a good time for you to pause the video and then try 2A and 2B here on the bottom, and then start up the video when you're finished. All right, so guided practice problem 2A here. So we're going to do our numbers first. So we're going to our coefficients. 3 times 7 is 21. And then I'm going to do y to the 4th and y to the 5th, and that is going to give me y to the 9th power because we're adding 4 and 5 to get 9 as our exponent, right? 2b is the same thing, right? Let's do our numbers first. So we have -4 and -6, so we'll multiply those and we get positive 24. Let's do r. We've got an r there, and we've got r to the 5th here. So remember this r, even though it doesn't have an exponent listed, it's 1. So it's 1 plus 5, so it's r to the 6th. That's a really common mistake I see people do. And then my x's, I have 2 here, and then I have 2 here, so we have 4 altogether. And then my t's, I have 3 here, and then I have 1 over here, so you have t to the 4th power. So this would be your finished answers right here. 2a is 21y to the 9th, and 2b is 24r to the 6th power, x to the 4th power, and t also raised to the 4th power. So I hope this is starting to make a little sense with you. It's just a bunch of new rules and applying them to certain situations. But pretty much we're still combining like terms, which we seem to do a lot of in algebra. All right, next video we're going to talk about what do we do when we take a power of a power.